Can you hear me? So can you hear me?
Yeah, a little bit broken. So I'm not sure other participants. So can you hear Professor Rifat?
Yes, sir.
Can you hear me clearly? Okay. So, okay. Thank you, sir, for your introduction. So I will start. I will share my screen first, and then I'll start. 1 minute.
So participants, if you face any difficulties like hearing voice or something, you can just like write in chat, and Professor Rifat can look at it. Like you can just write.
Okay, yeah. Just please let me know.
Yeah.
I think you can see my screen, sir. Sir, you can see my screen? In a presentation mode, I think. Can anyone confirm me, please, whether you can see my screen?
Yes, sir, it's coming, sir. Presentation is coming.
Okay. Yeah, the whole presentation, right? You can see the.
Yeah, your whole window is coming. No problem. Sir.
Okay, thank you. Yeah, so today I will be discussing a little bit, I'll say a little bit about NoSQL databases. So NoSQL database is not a new technology, but uh, like not like a recent new technology. It is a new technology, but it's there from like from a, for a very long time, and it's evolving a lot. And just to keep in mind, so uh, like maybe a couple of years ago, people think about NoSQL technology. These are like some kind of toy databases you can use for your pet projects or like class projects, something like that. But things are not being the same. They are evolving a lot, and they are actually like competing with state of the art relational database management system. So before I go into the start of my presentation, I think I saw the detail of your program. So I think there was a lecture of relational database, SQL, entity relationship diagram. So I think those things will come a little bit handy for today's talk. So what is a NoSQL database? So if we can say in a term, so NoSQL stands for no relational, no RDMS, and not only SQL. So sometimes people misunderstood that NoSQL means no SQL, but the term actually means not only SQL. So actually NoSQL is an umbrella item for all the databases and data stores that don't follow the relational database management system principles. So there are a variety class of products and several concepts that actually deals with both data storage and manipulation. And in most of the cases, NoSQL database often related to large data sets. So if we can just give a very formal definition from their formal website, which is www.nosqldatabase.org, we will explain this term a bit in our presentation. So NoSQL definition is kind of non-relational, it's distributed, open source, horizontal scalable, schema free, easy replication support, simple APIs, eventually consistent, or some say this as base property, not ACID. So ACID property is for RDMS, and it most of the times deal with huge data. So we will come to each of the part a little bit later in our presentation. So where does it come from? So non-relational database are not new. In most of the major commercial relational database system, they have some form of data stores where they can actually store data violating the relational principle. But those are not new. But the motivation of NoSQL, this is uh, thing. Someone is saying, can I share it on a full screen? Let's see. So you are not seeing as a full screen, or you can see the next slide as well. Can anyone confirm? Because I have a dual display. So are you seeing the full screen, or you can see
Just first slide, sir.
just first slide? I'm now in slide number 4.
No, it's not moving.
Oh, it's not moving. Just give me a minute. Just give me a minute. First slide. Oh, no, I am already made it full screen, but I think my dual display is creating the problem. Just give me 1 minute. Can you see slide number 4 now? No? Yes. Okay. Thank you. So, okay, just let me start. So where does it come from? So non-relational DBMS are not new, but NoSQL actually presents a different kind of solution to a different kind of problem. And the main motivation was because there were suddenly there are huge data coming from internet, the terms that we sometimes mention as big data. So due to massively scalable internet applications, you need to have some kind of different thinking of how you can actually store those data other than storing it into a relational database. So the development actually starts with Google from one of their internal projects, which is known as Bigtable, which is very famous now, and Google actually use Bigtable for all their internal products. And the first research paper was published back in 2003. So this is at the beginning of my presentation, I said, this is not actually not a new technology, but it evolves a lot. And then there are some like significant contributions from two large companies. One is from Amazon through their NoSQL data, one of their NoSQL database, which is called Dynamo, and through Apache, through Hadoop. And then lot of products and interests come from large tech companies, including Facebook, Netflix, Yahoo, eBay, and IBM, and many more. So what is the relationship between NoSQL and big data? So NoSQL comes from internet, so thus it is often related to the big data. So like how large data can we call as big data? So we can say like over few terabytes of data, So that can actually start spanning multiple storage units. So if you have in your laptop, in your desktop, or in your server, you have some like hard disk, you have SSD, all are storage units. So if you can fit your data in one of those storage units, then this is not actually big. So like if you need to deal with big data, that data needs to be spanned multiple storage units. So what is the problem with that? So all the relational database, they can actually handle large amount of data, they claim, and they can actually like handle it quite nice. So why, like when the concept of big data comes, why actually people think about NoSQL? Because there are some different type of challenges. For example, efficiently storing and accessing those data is difficult, and even more difficult when we actually consider fault tolerance and backup. So for fault tolerance, you need to maybe employ more servers, and for backup, you need, so sometimes the backups itself become like big data. So moreover, manipulating large data sets involves running immensely parallel processes. And moreover, when you have those big data, the fundamental difference between the NoSQL and the RDMS is in relational database, you always have to have structured data. So you already, I'm sure you saw in your previous lecture. So when you work with relational database, you actually need to think about the system first. You need to like design an ERD, and from the ERD you will get some tables, their relations. Then you actually create those tables in the database, and then you store the data. But you always don't like have those flexibility that you actually create. You know beforehand that okay, my data will be of this specific structure. So for big data, most of the time the schema or the data metadata are actually not structured. Rather, they are sometimes semi-structured and sometimes totally unstructured. So those things are not efficiently, like RDMS are not designed to efficiently handle data which is not structured. So that's why actually then people think about some other alternatives of RDMS to store and process the data. So this is just a repetition. How do you actually get here? The explosion of social media sites, Facebook, Twitter, many like billions of users, like billions of texts, posts, so large amount of tweets, so large data. Moreover, there is a like continuous rise of cloud-based solution. I think some of you will heard about Amazon S3, which is actually not a database, but a simple storage solution. We will see some kind of the technologies behind those like Amazon S3 later in the slide. But those solutions actually, the Amazon S3 is not a relational database. So, but it actually handles like data of like millions or billions of users in cloud. Moreover, we are moving to dynamically typed languages like Python, Ruby, Groovy. When the relational databases were developed, then most of the like programming languages were like static type languages like C, C++, Java. So you know about the types beforehand. But the new dynamically typed language, not new, but like new rise, Python, Ruby, or Groovy, where the language is dynamically typed. So it actually have to handle different kind of like unstructured or semi-structured data among itself. So the rise of those languages or shift to those languages actually like calls for a different kind of database other than RDMS to store them. And moreover, the open source community, because all the majority of the uh, like commercial or state of the art RDMS are actually controlled by the top software companies like Oracle, Microsoft. The PostgreSQL is actually free, and MySQL is also like is a part of Oracle now. So open source want to have their footprint on these database technologies. So why relational database not suitable for big data? So the main thing is the context is internet, and relational database assume that the data are dense and largely uniform. So they are structured data, but we want to deal with unstructured or semi-structured data. So with massive sparse data sets, the typical storage mechanism and access methods of RDMS will get stretched. It's not like that. You can store those data in RDMS. You can store the data, but you will face challenges while storing the data. And the thing is, when you actually store the data, the main purpose is later you want to access it. So that will be more difficult if you don't have a efficient way of storing them. So that's why relational database is not suitable for big data. So if I just give a different what are the difference between SQL? So by SQL you can understand these are a relational database, because SQL is a query language for the relational database system, and NoSQL is not actually a query language. So NoSQL, all the different type of NoSQL have different type of query languages of their own. All the NoSQL databases have their own query languages. So SQL is actually used for relational database, whether NoSQL is used for non-relational or distributed database. Then SQL actually used on the database that are fixed or static or predefined schema, and NoSQL work on dynamic schema. SQL databases are not suited for hierarchical data storage, but NoSQL actually is suited for hierarchical data storage. The point number 4 is interesting. SQL, these databases are best suited for complex queries, but NoSQL databases are not so good for complex queries. SQL databases or RDMS are vertically scalable. We will see that later, but NoSQL is horizontally scalable. And SQL or RDMS database, they follows the ACID property, atomicity, consistency, isolation, durability. Those are all fantastic principles for RDMS. But NoSQL database, in most of the NoSQL databases, they don't follow ACID property at all. Rather, they follow another property or theorem, which is called CAP. We'll see a little bit of CAP later in the slide. So just to give a brief overview of what I explained up to these slides, the distinguished characteristics of NoSQL is it works with large data volumes. The replication and distribution are scalable, potentially in thousands of machines, and those machines are distributed around the world. The queries need to return answers quickly, and majority of them are query, few of them are updates. But in relational database, you will see there are no such thing as you will support mostly queries, there will be few updates. But in NoSQL database, the distinguished character is in most of the times, once you store the data, you will carry out fewer updates. Rather, you will have mostly queries on those updates. Asynchronous inserts and updates. Most of the time, they're schemaless. You don't need to have a predefined schema like for RDMS, when you prepare the schema by designing an ERD or by have your own design and then creating those tables. But in NoSQL database, you don't actually use those kind of schema, pre-schema before you. So without using any schema, you can actually store your data, you can query them, you can update, delete them. So this is a different kind of avenue for people who want to work with their data. So moreover, ACID transaction properties are not needed for NoSQL. Rather, they use Bayes and CAP theorem. And most of the NoSQL databases are driven by open source development. So the thing that came can came to your mind whether NoSQL database is actually good, like are actually people or like using them. So if you can see, this is just a like a very like specific picture. You can see a little bit of like some like major companies and the NoSQL databases that use. So like Cassandra is a like very popular NoSQL database used by Facebook, Twitter, Rackspace, Reddit. Baidu use Hypertable, Google use Bigtable. Those are all NoSQL database. LinkedIn use Project Voldemort. You definitely know the name Voldemort if you're a fan of Harry Potter. Then Amazon, they use Dynamo, their own database. So these are all big companies. They actually used uh, NoSQL database for their operation, storing their data and then did numerous operations on them. And to name few popular NoSQL database, this is just from internet. These are some very popular NoSQL database. Maybe in the later part of our talk, we'll see one or two of them in detail. So MongoDB, which is a very famous, like one of the very famous NoSQL database. Redis, Cassandra, HBase, Neo4j. Like someone may be shocked to see Oracle here, but this Oracle is not the like RDMS. Oracle includes like a NoSQL like database of their own. So Oracle has a NoSQL database of their own. This is the Oracle NoSQL database. DynamoDB of Amazon, CouchDB. So these are some popular NoSQL databases. So these are just little bit about the background of NoSQL databases. So then I will actually move to some specific NoSQL databases that are like you can see there are these four are the major NoSQL database that exists today. So we can actually categorize them in four groups. One is document databases, key value store, column store, and graph database. So document database is actually store a complex data structure or document just by pairing it with a key. We'll see how it's stored in the later slide. So you have a key, and with each key you store a complex data structure or documents. Then comes key value store. So here with each key you store a simply value. So this is just if you have any idea about like hash or hash maps. So key value store, you can think about a hash maps that can actually store like billions of rows and still scalable. So that is key value store. Then column store. So column store is kind of totally different concept than what we have in our RDMS. In relational database, we have row and each row contains a number of columns. And here in column store for large database, they actually store columns of data together. So here in RDMS, maybe you have a large table with maybe 100 of rows. Each rows may have 10, 20 columns, but in column store, you have maybe 10 column families, where each family contains 2 or 3 columns, and they are stored together. And it was seen for some kind of queries, whether you want to just access few columns of a database. Column store are very efficient than traditional row-based RDMS. And then the last one, which is graph databases. This is actually, if you have knowledge about graph, so graph databases actually stored a graph as a database, and you can actually query on that databases just like as you're querying a graph. So if I move on, so these are, now I'll try to just focus a bit more on each of those 4 categories of NoSQL database. So those 4 are actually the 4 major categories. If you search internet, you will actually maybe find some other form of NoSQL databases, but these 4 are the 4 major ones. So first of all, the document databases. The document databases, what it did, it loosely structured set of key value pairs in documents. So as a key, you have a unique key, but as a value, you have a large document. We will see what a document means. And the documents are treated as a whole. So you don't need to avoid splitting a document to multiple like name value pairs. And any documents can be retrieved by a key and also by contents. For example, these 2 are the famous document databases available. One is MongoDB, used by GitHub, Foursquare, and many more. And another one is CouchDB, which is used by Apple, BBC, and those companies. So the central concept is the notion of a document which actually corresponds to a row in data RDMS. So in RDMS, you can see a document is a row with multiple columns. And I am pressing this a bit more, multiple columns which are specified beforehand. So in RDMS, when you want to store or insert a row into a database, you know beforehand that this row will have 20 columns or 10 columns in it, and you need to insert the data following that specific structure. And now you can see for document database, you can think this the total number of 20 columns or 10 columns, the whole thing as a document. So for a specific row, you have 10 columns in RDMS, and in document databases, you can think of the like 10 columns together is actually a document. So what is the difference? The difference is in RDMS, you need to define those columns beforehand, but in NoSQL, you don't need to define those columns beforehand because there is no such columns. You have just a document. So in a same database or in a same in a same table, you can have one document maybe with 5 properties. You can have another document with maybe 4 properties. Another can be 10 properties, and then properties. Some of the properties can be similar. Some of the properties may be very specific to a particular document. So this is possible in NoSQL database. You don't need to specify what you want to store beforehand. Rather, you store them on the fly. So documents are schema free. Different documents can have structures and schema that differ from one another, where, as I said just a bit ago, RDMS require that each row contains the same columns. But this requirement is not true for document databases or NoSQL databases. So here you can see a sample data for a document databases, which is a MongoDB. So here for MongoDB, this is a document. The top ID, which is mentioned as object ID, is actually the ID generated by the database. So you don't need to provide that, but you can have your own key. You can actually have your own key as a attribute in the document. That's totally up to you, but it automatically assigns the ID. So in the first document, you can see you have type, author, title, date, and the body. And in the same table, you have a type, you have an author, title, an ISBN. So you don't have ISBN in the first document, and you don't have date and body in the second document. So this is not like directly possible in RDMS. If you want to design this RDMS, then you need to know for all the documents what will be the possible columns, which sometimes is very difficult to identify. But for NoSQL database, or specifically for document database, you can actually store these documents in the same table with different attributes for different or individual documents. So this is the example of MongoDB. Then comes another major NoSQL database, which we call key value stores. So this is easy. And this is very important because in one point of time, you can actually, except the graph database, you can actually think of most of the NoSQL databases, including the document store, actually all are key value stores. So in traditional key value store databases, the values are like quite small, but in document databases, the documents are quite large. So that's one of the difference. But otherwise, fundamentally, they are like most of the time are actually key value stores. So this is an important type of NoSQL data. So similar, what it did, it actually stored data in a schema-less way. This is true for any NoSQL database. Store data as maps. So you can have either hash maps or any other of associative arrays. So here you can see in a figure, you have a name and a value. So all those are keys, and with keys, you have some value stored in them. So using simple like put operations, you can specify a key and a value. So the data store will automatically store the value with that key. Using the key, you can actually get back the value. These operations is simply called get. So these operations are available for key value stores. But interestingly, they are very efficient and scalable. If you can think of is a hash map, scalable hash maps is very difficult to implement, but NoSQL databases, those are key value stores. They actually did with they actually build a scalable hash maps that can actually store billions and billions of entries. But while doing so, you can easily access those data in a very fast way. So I will not go a bit technical detail in hash maps, because if you have idea of hash maps, you actually know that there can be collusion in hash maps, but this kind of things are solved for key value stores. So this is a fundamental ideas for NoSQL database, and key value stores are the simplest examples of NoSQL database. And you will see when I specify the examples that many of the big companies are actually using it. One of the example is Redis, then Dynamo, Cassandra, Voldemort, and you can see the number of companies actually use them. Redis is used by Craigslist, Instagram, Stack Overflow, Flickr, and many more. Amazon Dynamo is obviously used by Amazon, LCBR, IMDb. Apache Cassandra is used by Facebook. I mentioned earlier in a picture a few slides ago. Twitter, Voldemort is used by LinkedIn, eBay, and many more. So these are not actually toy databases anymore. These are all full-scale, sophisticated NoSQL database that is used by big tech companies for their operation in production. So they are important. Then column stores. This is third kind of major NoSQL database types. Here, data are stored in a column-oriented way. So you can see in the picture, the cells is actually so you have those in a in RDMS, you have those rows, and in column store, you actually divide those in some columns. Suppose you have a column family of products, you have column family of customers. So data are stored in a column-oriented way, and data are efficiently stored. And by doing so, you actually avoid space or a number of null attributes. When you work with RDMS, some of the columns that don't have any data on it, you actually sometimes store null. So column store actually avoid the space for those nulls. Column can be grouped in column families, and for each families or each column, you have a row key. For example, in the figure, you can see the IDs. You can actually have some row key to access that. So here you can see, let's see. I just checked the chat. Someone sent a message. So yeah. So this is just a like opposite like concept of row order or row measure databases. You can think of uh, this is just the only way of the basic way of doing this is to retrieve the data stored in these databases in a very efficient way. So sometimes, for example, if you have a row and you are actually rows are stored together, and the size of, for example, the size, if you consider in the RDMS, all the data are stored somewhere in the disk, and when you like do a query, you need to search that disk, load that data, and then separate out those columns. But in column store, you actually group those columns together that you actually need. So most of the times when you do a query, by just like searching a simple family will give you all the data you need, rather than searching all the rows or all the columns of a specific row. So that's the advantages of column store. And one of the like best examples of column store is the big table, which is introduced by Google. And this is like one of the, like, if we can see the three fundamental piece of works that actually streamline NoSQL. Big table is one of them. So, and it's also the first one. And there is another column store which is very like widely used, which is HBase. And in the previous slide, I show you the Apache Cassandra. So Cassandra is actually a key value store, but you will find in some of the blog or in documents that it also can be classified as a column store because they are quite similar. And the next one is what we call the graph databases. So the graph databases is the fourth major kind of NoSQL databases, which is actually graph oriented. So everything is stored, every data is stored as an age, a node, or an attribute. So each node or an age can have any number of attributes. I'll show you a picture just in the next slide. So both the nodes and age can be labeled, and label can be used to narrow searches. Some of the examples of graph databases are Neo4j, the most popular graph databases, and CloudDB and others. So if you want to like briefly give a better understand of graph databases, suppose in the left hand side we can see graph databases where we can see there is all the circles, those are nodes, and ages are, here you can see there are four nodes. One is a person, Keanu Reeves. One is a movie. One is a person, Andy, and another movie, which is Matrix and John Wick. And there are three ages. One is acted in, two acted in, and one directed. So these are ages. attribute of ages, and you can see there is level as well. The role just behind at the bottom of the acted in. So role neo, role weak. So actually, those are the level for that specific age. Similarly, the you can have extra level. As I can see, you can any number of attributes in a node. So in the person node, you have the name of the person and when he is born. In the movie node, you have the name of the movie and which year it was released. So this is a graph database, or you can clearly understand any kind of social network or social connections you can actually easily stored in a graph database. So here, what it means, the Keanu Reeves acted in the movie Matrix and also acted in the movie John Wick, and Andy Wachowski actually directed the movie The Matrix. And there can be other like nodes or age as well. Now, how about if I want to just store this information in a RDMS? So then you need to have at least those 4 entities. One is or relationship. What I can say, there can be entities or relationship. One is movies. You have entity or relationship for actors, for directors, and people, right? So these are the like some definite like very small ERD or for the specific graph database mentioned in the left. So the issue is the RDMS are not actually designed for graph queries. So when you want to traverse that graph, suppose you want to know the movie Matrix, which was directed by Andy Wachowski, what are the other movies directed by Andy, and like some other more deep queries. But these queries are very easy by querying a graph, but just one level of this graph traversal is very difficult to implement using RDMS. Because when you design RDMS, you don't actually consider that you can actually store graphs. So so there is no way to store graphs. Rather, what you did, you have to store all the nodes, ages, their levels into some data in your RDMS. If you are successful, then you need to do the queries. So by 1 or 2 depth queries, you need to have maybe 4 or 5 joins in them. But those queries will be very easy to implement in graph database. So Neo4j, one of the most popular graph databases, you can actually create graphs there, and you did a lot of different queries, which is otherwise very difficult to do in any state-of-the-art relational database management system. So those are the 4 major categories of NoSQL database. If I just recap, you have document database. One of the prime example is MongoDB. You have key value store. One of the prime example is Redis, Cassandra. You have column store. One of the popular example is Cassandra itself. And then you have graph databases, where one of the prime example is Neo4j. And I just mentioned you 4 or 5 names, I think 6 or 7 names of relational databases. But if you can search the internet, I think right of today, you may be found more than 200 NoSQL database available now, more than 200. So all different kind of NoSQL databases actually solve different kind of problems. So just give me 1 minute. Okay, yeah. Sure. So move on to the next slide. So how those two databases, relational database and NoSQL, actually deals with big data and scalability. So the scalability issue comes up when the data set is just too big. So if we consider those two type of databases, one is RDMS and one other is NoSQL. So RDMS were actually not designed to be distributed, right? So traditional DBMS are best designed to run when on a single machine. So that's why we can see large servers, right? You have servers with many processor cores, now maybe terabytes of memories, like petabyte of storage. But all these are actually focused on relational RDMS that actually works well on a single like huge machine. But when the larger volumes of data or operations of data came up, then what we did, the best way is just increase the capacity of that server. So suppose you have 8-core processor on your database server, like move it to 16 cores. You have 128 gigabyte of memory, make it 512. So these things is known as scaling up or vertical scale. So relational database system actually works well with vertical scale. But NoSQL database system are actually designed or developed so that you can actually run it on cluster or multi-node. So you can actually distribute the NoSQL database. So when you have large volumes of data, then instead of make single machine powerful, you can add more machines. So this is known as scaling out or horizontal scaling. So horizontal scaling nowadays, because of the price, the less price of those machines, rather than those servers, it is always cost effective to use horizontal scaling, which is like supported by the NoSQL databases from their birth, because one of their main focus was so that they can run on multiple machines or second distributed. Then comes the basic properties that are present in RDMS but absent in NoSQL. One such thing I mentioned at the very beginning was the ACID property. So RDMS are all actually based on ACID properties. But NoSQL does not give importance to ACID properties. Some of them, in some cases, they completely ignores them. Because as just we saw in the previous slide, most of the NoSQL databases will be distributed and a large number of parallel queries will be run on them to support the big data. So this is actually difficult or nearly impossible to ensure ACID properties, because ACID properties are useful when you have long-running transactions, which is like the common case for those RDMS. But it won't work because it will keep resources blocked for a long time, which is not practical for NoSQL. So that's why NoSQL databases don't actually follow ACID properties. Rather, it has its own properties, which is known as base. So base means basically available, soft state, and eventually consistent. So the main characteristics of NoSQL with respect to transaction is weak consistency. That means if you have some kind of stale data, this is okay, but it will be consistent eventually. The availability first is the prior concern. So that's why it won't allow long-running transactions. It will always give best effort. Sometimes, this is important, approximate answers are okay. So if you have a NoSQL database and you want some answer, the RDMS will actually give you accurate answer, and to give you that accurate answer, maybe you need to do a lot of background processing. But for NoSQL, some of the NoSQL, the approximate answers is okay, so which is like good for some of the cases. So these are the common characteristics of NoSQL with respect to transactions. Then another theorem, I will not go into a bit detail, but this is like the second important paper that drives the development of NoSQL after Google's big table is the CAP theorem. So CAP theorem mentioned at least two of the following three properties can be addressed. And those three properties are consistency, availability, and partition tolerance. So you can actually have, you can never have those three properties, but you can have any of the two, and to get that, you need to sacrifice another. So now talk about performance, because you know, in today's time, we all actually care about performance. If you design a NoSQL databases, which is very sophisticated, the queries are very easy, maybe you can write queries in human readable language, but at the end of the day, if your performance is not up to the mark, the people won't use it. They will just use it for their toy projects. So if you consider the performance of NoSQL databases, one thing, this is very important, there is no perfect NoSQL database, right? So every database has its advantages or disadvantages. Which one you choose is actually depends on the type of the task that you want to accomplish. So generally, NoSQL is actually a set of concepts, ideas, technologies, and software that works with big data, which is sparse, unstructured but semi-structured. You want high horizontal scalability, and you want massively parallel processing. So based on your requirement, you have to choose your NoSQL database, and you need to work on that. But if I am to give a rough estimation of the performance, let's have a look at one real example. So this is a statistic about Facebook search. When Facebook uses MySQL data, Facebook uses like some form of PHP and MySQL as its like main database. When the MySQL have greater than or 50 gigabytes of data, for Facebook search, the write took on average 300 milliseconds, and interestingly, the read took on average 350 milliseconds. But when they rewritten the search with Cassandra for similar amount of data, the write came down to 0.12 milliseconds and the reads average came down to 15 milliseconds. So that's the performance improvement the NoSQL database can give you when you have a huge volume of data, which is unstructured. And that's why Facebook did that and like achieved a significant performance improvement. So next, the common question can be when or where I should use NoSQL databases. We're just at the end of this, quite at the very end of this presentation. So I think we'll understand some of this already. So when we have geographically distributed architecture instead of expensive monolithic architecture, then you can think of NoSQL. When you have a large volumes of data, which is rapidly changing, and not all of them are structured, then you need to change of NoSQL data. When you have, so for example, in software engineering, there are now the development are done in sprints, and the methodology that everyone actually use are agile. So you can see a lot of the time, one of the main bottlenecks is change of fields or change of columns in your database. So when relational database, you you design your system, then you design the ERD, then from the ERD you created the table, but you have to change that table multiple times during your development. And maybe after development during production or during delivery, you also need to add some fields based on your customer feedback. And these things are quite difficult to implement in relational database system. But for NoSQL, you don't have any schema at all. So these things are very easy to handle. Right? So in these cases, when your requirement or database fields are changing a lot, then maybe you need to think different ideas than relational database. Then the relational database, this slide is interesting, or you can see it is also NoSQL is like a perfect storm. Large data sets, you have a large data set. People are acceptance of good alternatives, and dynamically typed data has come together in a perfect storm. So some people actually misunderstand this, that NoSQL is like a rebellion against RDMS. Not like that. And interestingly, you already know about SQL in your previous sessions. The language SQL itself is very rich, and it cannot be rivaled by any of the query languages provided by any of the NoSQL database currently available. So the richness of SQL is far beyond than the support of the query languages for those NoSQL databases. But then why you actually want to switch to or want to explore NoSQL databases? Maybe you have reached the point where the relational database isn't delivering the throughput necessary to support a particular application, which was the case for Facebook search. They use MySQL on a large servers, but still they reached a point that they are not delivering the throughput. MySQL is not delivering the throughput, so they move to Cassandra. So then you need to examine what alternatives are out there. Cassandra is not by Facebook, so Facebook did the same thing. Facebook examines what are the alternatives out there in the market that can actually increase the throughput of their site. So they choose Cassandra and replace MySQL for that specific part and achieve significant performance improvement. So NoSQL databases are a pragmatic response to growing scale of databases and the falling prices of commodity hardware, which might not be true now post-COVID, but pre-COVID, can say the price of those hardware were like uh, are reducing rapidly. So because NoSQL databases support horizontal scaling, that means you can add more machines to your system to improve your performance. That's why in those cases, NoSQL databases are fruitful. So if you can do a summary, like most likely 10 years from now, we will still see that most data will be still stored in RDMS. For example, if you consider a banking system, if you consider a ERP of a university of another institution, hardly you will see the application of NoSQL there. So most likely, if you consider volume, 10 years from now, you will still be seeing most data stored in RDMS. But leading users of NoSQL databases are so far social networking sites such as Twitter, Facebook, and LinkedIn. And this is also important is like NoSQL is actually taken a field that was dead, which is database development. All these commercial non-relational databases are there for a long time. So the DB development field was quite dead. But NoSQL has taken that dead field and suddenly brought it back to life. So that's all from me for the presentation. So you have any question? I don't know about the format, so I will take questions. Then maybe we'll take a break and not then start some hands-on or okay. So that's end of presentation from my side. Any question or any comments? You can also mention in chat. I think if you have any question, you can ask in the chat, and maybe I will answer considering reply to everyone. Am I audible? Like, can you hear me? Okay, thank you. So we'll take a break and maybe start in. Okay, yeah, I saw some. Name. Sir, are you there? Okay, then let's take a break of maybe 15 minutes or 20 minutes. Then okay, I will share those PPT. No, I'm not going to explain all the tools. This will be very difficult to explain all the tools in such a short time. But yeah, I will give you some references, some tutorials, and I will show some what I can see, some hands-on. So maybe this is so now it's 4:42 in my side, so it will be I think 4:12 I think in so let's start at 4:30 4:30 or 5 for my case. So maybe after 19 minutes we will take a short break of 19 minutes. So thank you.